This is the last lesson before review time. Okay, and the goal of today's lesson is to solve exponential equations. So what's going to happen this time when we're talking about exponential equations is we're going to have to solve for x, but this time x is going to be an exponent. It's a little bit different. So equations with exponents. So if we look at logically, if we had to solve the following, if we had 3 to the power of x equals 3 to the power of 4, and I asked you, what does x equal? Most of you would say automatically that x has to equal 4. And I would say to you, well, how do you know that? And you would say, well, just look at it. It has to be. And you're right, because logically it follows. Now, there actually is what we're going to talk about here is if the bases are the same, then the exponents must be equal. Okay, so they must be equal, so you need to add that to your note. So in this case, this left side equals right side. The bases are the same. Okay, they're both 3's. Therefore, these exponents must be equal. Now, obviously, the questions we're going to be looking at aren't going to be quite that easy to see. So let's look at, we're going to solve for x. The first question we're going to look at is two to the power of 2x plus 1 equals 2 to the power of 5. Well, let's take a look. Are the bases the same? Yes, they're both 2. Therefore, and so we're literally going to put therefore, as I get my pen up and running, therefore, the exponents, which is 2x plus 1, has to equal 5. Okay, it works the same way. Up here, 3x equals 3 to the fourth. Bases are the same. Therefore, you told me x equals 4. Logically, it still applies here. Now what I have is a small linear equation to solve. So I'm solving for x, so I'm going to subtract 1 from both sides. And then I'm going to divide both sides by 2. And when we do that, we end up with x equals 2. It's that simple. Next one, 5 equals 5 to the power of x minus 3. The bases are the same, therefore the exponents must be equal. My issue here is what exponent is there on this number 5? It can't be 0, other than this number here would be 1. So it's not 0, so it is 1. 5 to the power of 1 is 5, so that's correct. So that means, therefore, 1 has to equal x minus 3. So now I'm left with a very small equation, linear equation, that I can solve. How do I get x by itself? I'm going to add 3 to both sides. So I end up with 4 equals x. Okay? Now as we go on, what happens is sometimes the bases are not the same, but you do have the ability to make them the same. You can change them. So here's an example of what I'm talking about. So if I have one base as being 125, but the other base is 5, and I want the base to be 5, I should say. Right now, this is not equal. We all agree that 125 doesn't equal 5. In order to make it equal, I can change the number 5 to something, a power. And again, usually we're talking about things that are easy to use without our calculator. 5 to the power of 3 is the same as 125. Okay, so if I look at this one, 64 equals 2 to the power of something. So what I'm doing is I'm trying to calculate what the power is. So I could take my calculator and go 2 to the power of 3. No, that's only 32. If I try 2 to the power of 7, nope, that's too large. In fact, it's 2 to the power of 6. And again, sorry about that. Again, my lovely pen didn't want to work. So, okay, let's look at a couple more questions. Oh, 1 equals 3. Well, obviously 1 doesn't equal 3, so now I have to come up with something to change the 3 so it has. Okay, how do I make those equal? Well, remember one of the exponent laws? 3 to the 0 is the same as the number 1. And the same thing is true. I could then also do 1 also equals 4 to the 0. So anytime I want to change the number 1 to a different base, if I want a base of 5, I could go 5 to the 0. So that's pretty good. Okay, so let's look at an actual question where I have to change the base. So this is going to be my working example. And I'm starting with 32 equals 2 to the power 3x minus 5. Now you can see that my bases are not equal. So remember, our statement was if the bases are equal. So they aren't. So the first thing I have to do is I have to make the bases the same. And the way that we make them the same is I have to change, I'm not going to be able to change the number 2. I'm going to have to change the number 32. So I'm always going to take the larger one. So 32 equals 2 to the something. Okay? And it always will be that you can change it. So 2 to the power of what equals 32? Well, if I do some calculating, I could take my calculator, I could go 2 to the power 3. That's 8. Too small. 2 to the power of 4. That's 16. 2 to the power of 5 is 32. So that's the first thing I'm going to do. I'm going to go over here to the question and I'm going to change 32 so it is 2 to the power of 5. Okay, so I haven't changed the value of that. That's still equal 32 equals 2 to the power of 3x minus 5. Now you can see my bases are the same. Now because the bases are the same, then therefore the exponents are equal. So now I can finish the question by going therefore, just like the questions we did further up, therefore 5 has to equal the 3x minus 5. Okay, so we have a little linear equation we have to solve. We want x by itself, so we're going to add 5 to both sides. So 5 plus 5 is going to equal. So we're going to add 5 here, add 5 here, and we end up with 10 equals 3x. Then to get x by itself, we're going to divide both sides by 3. And we're left with our x is going to equal 10 divided by 3, and we would leave it as an improper fraction. Okay, so I don't want to change that to 3 decimal 1 repeating, I think it turns out to be. Or actually 3 decimal 3 repeating or something. So we want to leave it as a fraction. Okay, so we're going to do a few more questions and then you're off on your own.